Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to talk about detecting chemical in the universe. But first, let's start with the history of our universe. So, this is a clip of Big Bang. History of our universe started from hot and infinitely dense point and only a few millimeters to become small universe to the vast. In hadron epoch, the universe cooled down enough for quark to turn to proton and neutron. The proton and neutron fused and created nuclei which produced the first gases of our universe, helium. Much later after that, gases slowly clumped together by gravity and intermolecular force, called a nebula. Once clumped enough, the attraction and friction produce high enough heat to cause fusion reaction to occur, producing the first star. Fusion produces increasingly heavier elements, from hydrogen to helium to carbon to neon to oxygen to silicon to iron. Afterwards, the core collapsed, either degrading to a white dwarf or a massively dense object, such as neutron stars and black holes, leaving behind much heavier chemical and gases for a new nebula to form, completing a cycle of life for stars.
So now you know there are vast amounts of chemicals in the universe. But the question is how do we detect the chemicals in the universe? As we all know, the Milky Way is filled with enormous islands of gas. These clouds grow from the radiation of super bright stars shining nearby. Astronomers discovered the nature of these clouds by studying the colors of light their glowing gas emits. When we spread the light, the gas emits lines of a spectrum. As you can see, these are the spectrums made by the elements of the periodic table. For instance, in the Southern Crab Nebula, you can see the colors of oxygen, hydrogen, nitrogen, and sulfur in their respective colors. When a star energizes an atom of a gas, the electrons jump into a higher orbit. When it relaxes, the atom drops down to their normal orbits, emitting out energy as colored lights, or we call photons. In a dark and cold gas clouds, there are no stars to energize them, no electrons jumping to other orbits to emit photons. So how do we study what are they made of? Well, not all photons are visible. Visible light are a small portion of the spectrum. Higher wavelengths are the radio waves that are long for our eyes to see. Clouds that are too dark are actually shining in radio light. Large radio telescopes are built to gather these waves for the dark areas of space. The wave strength of the radio colors or frequencies are made to a radio spectrum. By radio spectroscopy, we discover dozens of complex molecules in these dark clouds and throughout space, such as glycine, anthracene, acetaldehyde, dimethyl ether, and acetaldehyde. These complex molecules do not emit photons by jumping of electrons between orbits. They instead radiate weak radio waves whenever they change rotational speed. Many of the molecules we found are the building blocks of life on Earth. Astronomers built powerful radio telescopes capable of detecting fainter and weaker signals, while chemists build laboratories that recreate the situation which molecules form in space. They study how the molecules grow and transform on the surface of tiny dust grains and in near vacuum found in molecular clouds. This astrochemistry collaboration will one day uncover the cosmic origins of the complex molecules that made life possible. And that is all from us. Thank you very much for watching and have a nice day.